Hello, Professor, and welcome to my adder and subtractor lab. So, for the adder module, we have inputs carry in, A, B, and then outputs S and carry out. So we have all that. Then we have the wire carry out 3. So this one's a continuation of the last lab. So because of that, it calls the ripple carry 4 right here. So with the ripple carry 4, it replaces each of its inputs and outputs with the inputs and outputs from here. So carry in A 3 to 0 and B 3 to 0 for the inputs, and then S 3 to 0 and carry out 3 for the outputs. And then it has carry out 3, A74, B74 for inputs, and then S74 and carry out for the outputs. So yep, that's the whole one. Pretty short, pretty quick and simple. Then we have the subtractor. Once again, still continuing from the last lab. So it has inputs, borrow in, and then inputs A and B, and then output difference, and then output borrow out, with the wire from 7 to 0 for E just being a just a variable. So we do an XOR logic table for each of these inputs and outputs. So we start with E0, B0 for the inputs, and then outputs borrow in, and it does that 7 more times for 0 to 7 for 8 total XOR gates, with each output being borrow in. And then we call the Adder8, which is this module. So we call Adder8, and then you replace the inputs here, which is also you replace the inputs and outputs here for these inputs and outputs. So borrow in A, and then E, and then difference, and borrow out. So yeah, like the last one, pretty quick, pretty simple. So if you look at the schematic, you see here it has 8 XOR gates from the 8 separate XOR gates here. And you can see that 0, 1, 2, 3, 4, they're all numbered. They take in the 2 inputs, output, whatever the output is. And then we move on to here, which is the Adder8, which is this module. So we open it up, and you can see that it calls a ripple carry like it did before. So it takes in the inputs of A and B and carry in, and outputs carry out and S, which is sum. As you can see, it has those 3 inputs and those 2 outputs, so they match. When you look inside the ripple carry, you'll see that it calls the full adder from the last lab. Look inside one of the full adders, you can see that it calls half adders. So yeah, so that's how it all continues from the last lab. And then it outputs the carry out, and the sum gets put over here and joins with the other sum, and it turns into this output. And the carry out is used for the carrying over here. And then previous inputs are used for this. Same thing as before. Calls for full adder. Oh, what did I do? Sorry. Calls full adder, and then it calls, half adder, and then it does all that. So we zoom back out. So yep, that's the schematic. So then we can look at the simulation, or the timing diagram. Well, I guess first look at the test bench. So here's the test bench, registers A0, sub 1, and then AB, wire, sum, difference, carry, borrow. Integer I, then we call the adder and the subtractor, replace their inputs and outputs with these inputs and outputs. Sum and carry for adder, difference and borrow for subtractor. Then we start running a for loop. So it takes in the inputs and does a test case. Sorry. So it goes to the test case down here. This is really where everything happens. This is kind of just for visual purposes. This is really where everything happens. So if add 0 sub 1 is equal to 0, meaning that if it's going to add 2 numbers, or I guess 2 what are they called? Binary numbers. Then it runs through this and adds them, displays them with the sums and carries. Else, if it's going to be to number the subtractor, so subtractor test, It does A minus B. Run through all this using difference and borrow. Then it ends and it ends task. So with that, we have this timing diagram. So you can see it has each of the different inputs and outputs for each possible sum or difference or adders, subtractors, and all that. Pretty simple. Goes up to 9. Yeah. So I guess, well, yeah, so it goes up to 10, 0 to 9 is 10, which is how many times we ran through it over here. And then if we look at the output down here, you can see that it matches the one in the instructions. So see, this one did an adder test, resulted in that, carry 1, subtractor test, resulted in this, carried 1, and then I went through it 8 more times for a total of 10 times for each possible adder and subtractor. And all of those values show in here. So you see the ones where there is a carry one, it is highlighted. When there isn't a carry, it's blanked out. So we look back up here. This one is a carry one, so that one was highlighted. And then the same thing happens with the borrows. Borrows one here, highlight one. So yeah, pretty simple lab. So yeah, that's it. Thank you. Oh, it didn't stop.